Hey, hello, welcome. Let's try to solve another Leetcode problem. 2462, total cost to hire K workers. And so the problem is that we are giving a cost array, and we are also giving an integer K and candidates. So the meaning of the candidates is that, so for example, the candidates is 4. It means we're gonna choose from the first 4 candidates from the first part of the cost array. So it means from those 4 numbers we can choose a number, so for each of the round. And for the candidates equal to 4, it also means from the last 4 candidates, we can also choose a number which is going to be the smallest. So let me maybe make a drawing like the first example. So we have 17, 12, 10, 2, 7, 2, 11, 20, and 8. Yeah, so this is our array. So this means from the first 4 candidates, we're gonna put those values inside a heap because we are going to take the minimum value. So I'm gonna call it a pre-heap. And also for the last 4 candidates, so this is gonna be the last 4 candidates. So from the last candidates, it means the last 4 numbers. Basically, it is 2, 11, 20, and 8. So we're gonna prepare a heap. So this is gonna be the suffix. So according to the prefix and suffix, we're gonna choose the minimum value. So if the minimum value is coming from the prefix, so from here, yeah, and this value 2 is less than or equal to the suffix value, so it means we're gonna take it from the prefix. Yeah, because this 2 is less than or equal to this 2. According to the question, we're gonna choose the minimum smaller index. So this index for this 2 is smaller, so we're gonna choose it from here. Yeah. So this is the first round, and then the K gonna minus 1, and we're gonna go to the second round. So for the second round, as this 2 goes out of the prefix heap, goes out of the pre-heap, so we're gonna put the 7. Yeah. So for the next round, we're gonna also choose the first four numbers from the first part of the array. So we're gonna put the 7 inside. But for the suffix array, it is okay because there are 4 numbers. So now we don't have this 2, but we have a 7. So for the next round, we're gonna take out this 2. So it means 2 plus 2 is gonna be equal to 4. So currently for the suffix array, there are only 3 numbers, but we need to have 4 numbers, but there's no numbers inside. Yeah. So it means, it means there's no numbers to take. So we're gonna just keep 3 numbers. Yeah. So this is gonna be the suffix array, and this is gonna be the prefix array. And for the next round, it's gonna be the third round. We're gonna choose the minimum number from the prefix and the suffix. So from the prefix, it's gonna be 7. So from the suffix, it's gonna be 8. So we're gonna choose 7. So 2 plus 2 plus 7, it's gonna be 11. It's gonna be the final result. So this is the idea. But exactly how can we solve the problem easily? Yeah, because sometimes you need to check if it goes out of the range, because this is an index. Maybe there's an intersection. So how should we deal with the intersection? So the intersection is okay. So if there is an intersection, basically means we can choose the first K elements from the whole array. Because there is intersection, definitely we can choose it from the whole array. But what if there's no intersection? For example, this is going to be the first part, and this is going to be the second part. But while we delete some numbers and increase some numbers, it's going to be shifted, and the last part is also going to be shifted. But there is no intersection. If there's no intersection, actually this is okay. We just need to, check K round, and for each round we just need to take the smallest value for each part. And if there is intersection, we need to have a check. Yeah, so if there is an intersection, basically means we can take all the numbers. We can just sort all the numbers and take the first K numbers. It's going to be okay. Yeah, so let's just use an example. Maybe we're going to use this example. So the first 4 numbers, it's going to be from here, 7 to 2, and the last 4 numbers are going to be from 4 to 8. Yeah, as K equal to 3, basically means if we take out 1 number, for example, if we take out 1 number from the first part, so normally we're going to take the 7 to this first part. Basically, if K equal to 1, so if K equal to 1, basically this means we can take out 1 number from the first part. For example, we take out this 2 from the first part, and then we're going to put the 7 inside. But we are not sure if we are going to take this 7 or not. So basically, this means if k equal to 2, we can use all elements of the array. Because if k equal to 2, definitely we're going to take an element from the first part or the second part, but definitely we will use all the elements. Yeah, because if k equal to 2, for the first part, we're going to include this 7. Let me make it more clear, maybe. Yeah. So if k equals to 2, up to now, we're going to use, we're going to take the 7 and take the 2 out. This means we're going to take the 4 numbers for the first part, and for the second part, for the last part, we're going to take another 4 numbers. And when k equal to 2, definitely we're going to choose a number either from the first part or from the second part. Definitely we're going to use all the numbers inside the cost array. So this means if 2 times candidates plus k is more than the length of the array, basically it means we can use all the numbers inside the cost array. We just need to sort it and take out the first k numbers. Yeah, if we can deal with this kind of condition, basically the second part is going to be easier, because for the second part, no matter how we shifted the first part or the second part, there's no intersection, and we can directly solve it. Yeah. Now let's just use this idea to solve the problem. So we're going to prepare n going to be length of the cost array. So we're going to have a check if 2 times the candidates plus the k is more than n. So this basically it means there is intersection. We can use all the elements inside the cost array. So we just need to sort it first. So we're gonna sort it, and we're gonna take out the first k numbers, and we're gonna sum up of all those values. So it's gonna be the cost of the first k candidates. So this is gonna be the answer. So otherwise, this means 2 times candidates plus k is going to be less than or equal to n, and we can directly find the index. So I'm going to prepare a result going to be equal to 0, and let me use a prefix and suffix array. So the prefix is going to be the first candidates, the first part. It's going to be the cost array to the candidates. And the suffix is going to be from the negative of candidates to the last part. And at the same time, we're going to prepare the index I and j. So I is going to be equal to the candidates. It means from the candidates position, we're going to take a number if it is from the first part. Otherwise, if it is from suffix, if it is from the suffix part, so we're going to take it from the suffix part. So it's going to be n minus 1 minus the candidates. Yeah. But for the prefix and suffix, we need to turn it to min heap. So we're going to use the heapify with prefix and heapify with the suffix. Yeah. Now we can use the toHeap to solve the problem. So let's first check how many round. So there will be k round. So for anything in range k, we need to have a check. So if pre0, it means on top of the heap, it's going to be the minimum number. It's less than or equal to the suffix 0. So what are we going to do? We can use heap pop. We're going to pop out to the smallest number, and we're going to basically we need 2 steps. First of all, it's going to be a heap pop. So we're going to heap pop from the prefix, and then we're going to use a heap push. Also, it's going to be the prefix. It's going to be the costs with I, because I equal to the candidates. Yeah, and then the I is going to plus equal to 1. But we can combine those two to 1. Yeah, because this is a pop and this is a push. So we just combine those 2 lines to 1. So we're gonna update the result. So the result is gonna equal to heap replace. Yeah, because the heap replace is basically the 2 steps, and it's gonna be much faster than the heap pop and push. Yeah. So inside it's gonna be pre, and with cost I. So we just need to delete those two lines because the heap replace is basically the pop and push operation, but we just need to use one method and it's much faster. And then if the pre-0 is less than sub-0, basically means we're gonna update the result to heap replace with the suffix, and it's gonna be the cost j, and similarly the j gonna be -1. Yeah, so we are safe for this I and j because there's no intersections with each other, because here is a check. That's basically it means from here I and j there's no intersections, we are safe. We don't need to check the I should always be less than or equal to j. Actually the I gonna be less than j, and it is always valid because here we have a check. Basically it means from here there's no intersections. And finally we just need to return the result. Yeah, so this is going to be the entire code. I think the difficult part maybe we need to analyze about this one. We have to check if there's intersections with all the values. Basically it means we can take all the values from the cost array, so we are safe, and we can directly return the sum of the costs from the first k values. Otherwise we can use two main heaps, the pre-heap and the suffix heap, and we just need to go for the k round and check for each of the time. So if the first value, minimum value inside the pre-heap is less than or equal to the sub-heap, and basically we need to replace the pre-heap with the cost and plus the value inside the result, and we're going to update the index I, and here we're going to update the index j. Now let me just run it to check. It seems it is not okay. Yeah, because I forget to use the costs. Let me just add the costs. Now it seems it is okay. Now let me just submit it. As you can see, it works and it's pretty fast. Thank you for watching. See you next time.